Yeah, so I'm just gonna open up my parts and make these changes to them and make copies. So that's my first thing. So open up existing files from this week. So, I'll do the ones that we did in class together. So with my six part one. I'll just read the class together. Oh, and I'll just open all. I'm gonna open all five here. No, so I'm just gonna go through them. Look like this thing. This thing. This thing. These are the chapters, the ones that we used last time. They're the chapter six. They were the little same little piston and piston case. Yeah, yeah. I'm gonna open them all. I'm gonna make copies of all of them. I'm not gonna mess up these ones that already exist because they're really in that other assembly that we built. But, they're functioning fine. If you start making adjustments on them as when the part is currently named, it will affect that other assembly. So we go chapter 7. Yeah, so I'm just opening them all up, some too many copies of them, and I'm just gonna have them open to modify them. So I can, you know, I'm not gonna use that other assembly. I'm gonna make a new assembly when I write assemblies. So yeah, in any order here, what I got a piston, got a wrist pin they call it, the piston case, crankshaft, and no, and then um, yeah. So what I'm going to do is I'm just going to make a copy of these. I've got it, so I'll get it. So now I'll get a new name of them so I can modify. You know, I'm just going to say file, save as. If you say copy as, and remember it'll just dump that file in your folder. You have to go reopen it. If you just say save as, it will just kind of do an overwrite of this one. I'm going to save it in. I've got a new folder here because I week three stuff to get my really big. So I have a new folder for my piston. Uh, my V-Twin Pistons, so I have its assemblies and parts here. I'm going to make myself one there, which is really cool. The last one. Yeah, so let's say that I simply that's it's color list. I don't even know if that's picture of mechanics term out. We'll call it. So, okay, so I got my five parts. I can just go through any of them. I'll just start with kind of the foundational part, which is the piston key. That's the first one I'm gonna. fix the sizing of. So got a new unique name, so now I can adjust it. The 3/4 size, I'm just going to go into my extrusion and change these dimensions to be 3/4 size. So there's some ways you could do this pretty easily. You could even just go into the f of x, which is all of your dimensions that you've ever entered. And you can modify the dimensions here. But that might be something that's a good way to modify stuff like this. Is sketch. Come in over your whole spreadsheet of the dimensions that I've used in this. I haven't renamed anything. You know, all of these things are renameable, like the sketch names, whether they're on the model tree here. Oh yeah, that is on the quick access. And there's the f of x. I think I'll go ahead and do mine within the sketch, but I'm just saying that you have access to all the dimensions within this part right here. I think, what's that? Oh yeah, I will. I will. Yeah, it's true. So all I've really done is just save all my parts as new names. That's how I got them here, and then just show that this f of x is pretty hidden up here, but pretty powerful. It gives you access to all your dimensions. If they're not named very strategically, it can be hard to know what's new. And so sometimes if designs are simple enough, you could, or if you have enough time, you're organized enough, you can rename your sketches, your extrusions, so when they populate on a spreadsheet and it's like this, they're a little bit more identifiable. Right here, this doesn't make a lot of sense to me, but I didn't look at exactly names. That's the argument for maybe, but it just takes more time, right? You have to go through and decide what the name, decide something that everybody's going to know what the name is. So I feel like there's somewhat of a need within the drafting department to set those standards so that we don't get a bunch of names that I think this is called, and it's really not what it's called. And it could be a mess, right? So sometimes it's easier just to keep it as these default names. But as the parts get complicated, it might be beneficial to spend extra time to identify sketches and features that they're noting. Even name with dimensions instead of just being B4, B3, B2. These could actually take on names. So it can get complicated. It can get or I should say, it can get really organized. And I would say that's probably hit and miss out in the industry of how organized it is, especially if it's production based. Time is always a key strength. And some other jobs with time isn't always pressure. Sometimes you can see better organized stuff. So what I'm going to do is I'll just kind of keep it simple. And this is kissing up with me. Just keep it simple, stupid here. Well, I'm just going to make my adjustments within the sketch, which I think we're used to adjusting these over here. These are overly complicated parts. I have 3 sketches to kind of go through and fix my dimensions. But I am just going to make these dimensions. If you'll notice my little thing I got passed around, there were some issues with it as I scale this down, and we'll discuss. I think I'm just going to go ahead and do all the dimensioning fixes and everything to kind of discuss on tolerances, and we'll discuss how to make some modifications for quality. But let's just first make the overall like 3/4 adjustment. So this is 3 inches. It needs to be like 3/4 of 3 inches. Like I think I mentioned, these things work separately. An equation essentially. So you could say, oh, times this by 0.75. That's the same difference. The time, is the little asterisk. So either shift 8 is the multiplication button, or I use the number pad that has a multiplication button right there. 0.75. It's actually a legit dimension, right? This is 3/4 of 3 inches. Now maybe that's not. I mean, I could do the math too, and then just type in this 2.25 number. I don't. So there's some, sometimes an equation isn't what you want there. Sometimes it is. This is a quick, easy way to do these changes. It's just to kind of divide 0.75, anything that I have. What is it? What did I do? Oh yeah, turn on your num lock. Because I use a 10 key flat. That's my. I mean, it always has been since CADD. This is where I enter. And so well, it could be, and that's not too critical either, because maybe yours is it's yeah, you could have it drawn just inverted for me or whatever, and that's okay with you. Yes. Yeah, if yours is different than mine, you may have constrained yours differently than mine. It's totally fine. As long as it's constrained, that's maybe mine is good. So I am wrong. No good. I think I don't know. Oh yeah, and then I've got some issues obviously in the comments. Yeah, evidently this was my sketch. And I could have extruded it centered over, halfway. There could be a reason why I'd want to. You can see that my extrusion is away from. I'm also going to edit that as well. And I'm going to take this extrusion. Not only did I just change the sketch, but I'm going to take the extrusion and this length. I'm also cutting down my 7.75 things. And it's just getting chopped. That's a good. Let's see here. That one there, the original extrusion is 2.25, and I'm 75% of that. So now I don't know if it's an equation, but I can make it. That actually cuts this down to that's not good. Actually, I think 1.6875. I think it's rounding to three dimensions. Yeah, 1.6875. That would be 6875. We all know that, right? That's not level. Oh yeah, and that's good. So because that just means that some of this might blow up on me. Mine is still functioning, but what it means is I just say accept and let it like crash what's down below it. You can always drag your if it's bugging, you can always drag your end of part up to kind of sets these things one at a time. If you fix the sketch, fix the extrusion, that one shouldn't blow up. It's probably the next one that's having issues. Could be some of your projected geometry is kind of weird now, but so then I can pull down this end of part here and go to the next step. This 0.75, yeah. Then it blows up. Yeah, it's because I think it's affecting stuff downstream, right? Is actually is it itself blowing up like its own extrusion, or is it the stuff below? Yeah, you can't. It won't accept this as an entry. Oh, it should. Yeah, because mine's not anything different. Yeah, I could even, yeah, the original, I don't put the units in. In fact, it can be issues if there are some weird units. I usually delete them out. Even when I do my dimensioning, I don't even worry about the units. It'll auto apply it. So this really can say 2.25 times 0.75. And I have no units at all in there, and it will apply. And when I say okay, because our units are in English and inches, so it knows that these dimensions are inches, and then it applies this way. I sometimes put a space in between my I don't know if that's a good habit, but it makes it easier for me to read and see and make adjustments. And when I do, if I needed to enter a different dimension here, I usually select the whole thing like this, and I'll be like, oh, actually, I only want it to be by 25, and I would make an adjustment like that. Let's see. Yeah. I mean, I'm just showing you that if stuff's blowing up on you, you can take this one step at a time, fix it. Um, you don't have to do that either. You can leave it at the end and just let everything blow up downstream from you if it does. Mine still is functioning okay. I mean, obviously my part looks like it's jacked up, but my extrusions and my sketches are not malfunctioning. And even if they are, I just hit accept and let the thing blow up, and then just kind of try to see if it's something downstream. I have a full face. I don't know how you guys did your fillet. That would probably need to be the size would need to be adjusted. I did a full face fillet, so I don't even have to worry about the size. I did those three face selections to do that fillet. Show what it looked like with that. I selected these three faces. If you get a size one, you just want to adjust that size, right? It'll be whatever half of this is. Now your fillet radius would be 1.6875. 1. Sorry, yeah, 1.6875. And know it's more around in Canada. Let's see. If we change it to the other type of filler, I'm guessing if your whole extrusion is probably based off a separate whole of uh, I'm gonna say, if you're just gonna fix your fill, so it would be like half of it. So your fillet would be like 84375 if you kind of 3/4 sides together from what you have. That would essentially depend if your original fillet. What's this one? However, look, you could pull up if you did two selections here, you'd be able to open that fillet with the niche here and times you can be able to enter point times 0.75. That should work. Yeah. Because otherwise, if you would delete that or want to do a different type of fillet, that will definitely affect stuff downstream, especially if you use the center hole on the radius of that fillet for the next extrusion, and then you change the fillet type or whatever. It's going to change everything downstream. So when you change features of geometry and you lose an edge that was there before, it's going to blow up projected sketches, and they're going to go pink, and they're going to have to be reselected and reconstructed. It's okay. It's something I have to worry about. But if I can prevent it, I will. And so I'm not going to change that feature. If you did yours as two selected, just two times that. I think the next thing I have to modify this more than this, but I think I can. I think I can sketch for my the next thing I do. That's just a big 2-inch hole. I don't want that. It's gonna be times 175, which is a 1.5 inch round. Here's one of my problems with mine is that if you look at mine and I pass it around, this is starting to get a little thin on the sides here. So that's one thing that I've noticed when I did mine, and I had to wallow mine out with a little bit of sandpaper and kind of work it over a little bit. So I'm like, ooh, I probably not want to go too much thinner than this. Yeah, so we'll look at that when we get to the end. I'm not gonna worry about it yet. It's just something that did catch my eye with my prototype, but I'm like a pretty thin walled on my cylinder or my piston board here. So not just it's like something that I'm aware of right now. It's something I could maybe fix better. And then the extrusion itself, I don't need to really fix it. You may have to if you had a dimension here. Mine was always through to that side. So as this thing has shrunk, I don't have any adjustment to make on my tooth here. And then and I have one more extrusion, which is just a little hole from where the this one here, which I just need to change its size as well. So let me go into this sketch. It was designed for a 1/2 inch hole, 1/2 inch crankshaft. Mine's going to be designed for a 3/8, which if I do times this one by 0.75, I will do it like 3/8 here. So I can do that. That's fine. Um, and then let me just jump over to the assignment. There is maybe a couple things. So that's all I'm doing is making these adjustments here. Oh yeah, that one I call out what the radius would be in case that's how you did mine. I think I had none. So these numbers are look a little bit different because they have some tolerance applied. We'll come back to that when we think about even at the assembly point, we can come back and start adding a tolerance of it. I need to add this stuff on though. So we're gonna make it a dual and V-twin here. And so let's just add, so I need to do a sketch where I think I add a 6-inch long extrusion here, the same. I think I sketched this one as a rectangle and projected some of the geometry from what already exists here, and kind of just let it melt itself together because it'll be a new body. So I'll show. So first I'll do that, and then I can build this little extrusion separately. So what I got to do is this 6. I think just a quick screenshot of this. Build from this over here. So I finished with that hole in there. Now I just need to add the V-twin, which either is going to come out this way or that way. I don't think it matters which way you come out on, right? Oh, it's technically mine going like this, and I came this way. If you came that way, it wouldn't matter. It's just that I think I did my sketch on this surface there, so I picked like the bottom of it, doing a new sketch here. I projected some geometry here. This edge here. Essentially, I kind of have like a rectangle. I'm just drawing a random rectangle out here. It's really 1.6875. Yeah. Tab over to here. I need to six. This is my 6 inch rectangle. To this one. Yeah, I changed the hole to, yep, it's a 3/8 hole, 0.375 or 0.5 times 0.7. It ends up being a 3/8 hole though. And essentially this thing is just going to come over here and sit over the top of this, right? I think this thing just sits right over like this. So I think I could do like tangent from this to this maybe. Then I just need to go like a coincident constraint, like this line to maybe the point here on there. That's all it takes for me to constrain like this random rectangle. It's not exactly how I want to how did I do that? Yeah, I did it with that's my geometric constraint. So really I just drew this random rectangle, it's aligned in my space and I'm perpendicular. Plus I even have these parallel stuff because I use the rectangle command. But then it's just a matter of geometrically constraining it in the space where you want it. So right now I have it dimensionally constrained. So if I drag it around, it goes where I want it to go in its shape. But I need it to sit over the top of this like this. Sometimes I move it close. Like if I drew a weird sketch, it's a long ways away. Sometimes I just drag it close to where I'm going to constrain it to. It will jump, but if you've noticed, sometimes what side of the geometric constraint you're on, or whatever geometry it is, sometimes it can put it where you don't want it. So sometimes I generally like will slide it closer to where I want it. And then I chose a tangent constraint on this vertical line and this projected geometry that I have. And that's all it takes to lock that shape in, at least in the X, well, I don't know what direction. I'm in the X direction. And in the Z, what is this, the Z direction? Yeah. I just used a coincident constraint, which could be, I just chose the line and then a point. Not everything, coincident constraints are kind of weird. Not everything works as a coincident constraint. That does work. That's a point and a line. And it's really not even I probably could have made tangent work there as well. So totally. It's like you could have gone tangent to there, and then this thing is a constrained sketch. And if you can see some of the grading I've done from week one, the only thing I'm really, catching some people on is mostly constrained sketches, And that's my big soapbox for the first couple of weeks. How you build your stuff is really not too like this always gets refined over time. So what I've got going on here is that I'm really just gonna add. I don't. This I'm gonna keep. The hole I'm gonna keep. So I don't really want to extrude this whole thing as this and then have to recut that or something. If you do that, it would work. You would just have to you can change the orders of what you did over there too, as long as they're not dependent on one another. Like I could actually switch the extrusion ahead of, like I could technically have drawn this first, then I can do the whole next, and I can really probably change that order of operations as long as the sketch itself isn't dependent on one. This one might be because I've got geometry that it would mess this one up because I'm using projected geometry from the hole and the fillet features. So if I try to mess up anyway, I'm trying to explain something I'm probably not going to be able to explain. But I am going to project one more piece of geometry here, maybe this right here, because what I really want to extrude is just kind of this little weird shape and out to there. So and I think I'll just leave this in as solid lines in this case because I'm just gonna let the thing cut through, and this will be a closed polygon here. I know it has extra here, but this is all I really want to extrude is in this area. So I'm just gonna say okay on this sketch. I'm gonna extrude this thing, this particular geometry, this stuff here. And I'm just going to extrude it the same as whatever this is here, which this is where I told you when you have like this measurement box or this little box in your data entry box, you can just say measure and I'll be like, oh, well, I want to extrude it like from here to here. And that dimension is this, and it applies it. What is it? Oh, how I measured that was this little box here. And it brings up this measurement tab, which kind of makes everything disappear weird, but you can measure, like it's nice to use it. I use my measurement tool a lot, just like I did in CAD a lot. But you can measure point to point, you can measure lines, you can measure face to face, like and then it just inputs that measurement into your data box. You just have to watch. Sometimes there's already some leftover data in your box, and you try to measurement, and it tries to add that together, and you get like if your dimensions ever go red, you'll know that you've got some conflict in there. Could be extra decimals, could be something that just doesn't make sense. So watch your dimension entry boxes in any place, and if they ever are red or something, it usually means you've got an error. It's like a syntax error kind of. Yeah, you get it here for sure, especially when you're writing equations or using equations kind of as dimensions. You can get an extra decimal in there or something. Anyway, this is okay. Like this is going to join it into this solid. That's what this is telling me. So this is the join. So these will, that's what I mean. They're gonna melt together. We're gonna essentially. And so it might mean, yeah. And if you unselect your profiles, can you go like, yeah, unselect them, which is like X amount. And once I've selected a profile, it'll have it. I can always X them out here and reselect profiles. If you cannot select this profile, I am suspicious that the tangent, you're not like, they're not touching where they should be. Yeah, because I technically have quite a few different little shapes here that are, that's the one I want. That's the dimension I want. I'm not making a new solid. I want it to join my solid. So let's say yes. This is kind of what it ends up as. Hmm. I don't love this. I don't love this seam here. I'd like to, so I feel like maybe the measurements are a little bit off of each other for some reason. Yeah, I can see that here. Kind of weird. Like the way I measured that, I didn't get yeah, because this isn't what I want. This is no bueno. This is no good. So let's go back in and edit that extrusion for me. I'm gonna really have to edit the extrusion, I think. Yep. Maybe I just measure like face to face. That's kind of weird. It's like rounding for me or something. And I don't want it to round. What is this? And this is another thing you can do. You can always copy paste. What does this measure? What does this measure? That is the same. It's really dumb that mine's like different. To get the right measurement here. That's really weird. It's because mine is maybe it's because mine is really which one are you seeing?
Use that. You put one of the edge lines
Right there. If I say measure this,
like that. It should be.
are your
I think you was wrong
are
there.
that's good. No, are your guys is doing good though?
That's
Oh, that's
what I
great.
did.
Oh, that's good. I'm gonna check this thickness here. It's really this dimension here, right? I think it's the rounding error that I have here. Let me go back into my original sketch, edit my sketch. I'm looking at this dimension as being kind of weird, 0.75 times that. So maybe this could be where I'm just going to try something. I don't know if it's going to work out, but I definitely have to fix it. This is my sketch one. Yeah, what's driving that original width here that I'm trying to match is this particular dimension, which is kind of odd. Maybe this made this part of my problem. Is 5625. I just wonder if that 563 and the difference between 5625 and 563 is what's causing my problem. So I'm going to enter this as the actual point 5625. What should be right on my calculator. 5625. Yeah, you can. Yes, you can do. Yes, you can increase its. And now I'm going to go in to my sketch. Oh, sorry about that. I need to on my screen. That's all it took me to fix mine. So mine was just the factor of the equation I had driving this dimension change was rounding probably for me to three decimal places. At least it's expressing, showing it that way. And maybe that's all I needed to do was just fix that. It's fix the precision of it. I just went in and fixed this dimension to actually be not the equation there. And that was just because I had a conflict. Now I have a perfectly melted together solid. So that's just something, I mean, that's something to pay attention to. I didn't know that. Yeah. It's all good. I got to finish this thing. We need some more. We got to draw some draw another cylinder bore that really matches this over here. So I think I just drew this. You can either draw it from this face and extend it. Yeah, that's probably what I'll do. I'll just use this face now for a new sketch. Yeah, and then mine's going. I'm going to project this geometry maybe. Yeah, to me, I'm just going to turn that to construction. You don't have to do this, but it's just because I'm going to draw another rectangle here that is like 2 and a 16th by the same width, whatever that is, 1.86875. So really in this direction, it's 1.6875. Yeah. But I don't have to drive that. That would be, I'll show you, maybe I might change that, but 2.0625, 2 and a 16th is what this ends up being. According to my picture on that I've uploaded, this face right here, this little end face. I'm really going to add, what I'm going to do is I'm going to add it as, I'm just going to join it to the solid here. So I'm going to draw this little sketch, whatever this is. So I just came to the end. Yep. And then draw this. And really, what I'm saying is, I don't even have to really drive this with a dimension. If I want my geometry to carry, if I want my geometry, projected geometry to kind of carry this, I can just, this is where I would use maybe a coincident constraint to the end point of this line, to the end point of my projected line. Same thing over here, another one from there to my projected point. That just, instead of having that's constrained now because it's driving off of, it's constrained to that projection geometry. And in the future, if I ever like change the width of this, then these will automatically stretch that way. If they're driven by the dimension, they won't. They'll have, you have to come back in and change them. And so right now I'm kind of minimizing. I'm going to change that width. And the reason why I'm thinking of that is because I thought I maybe am a little thin here once I do my tolerances here. And so if I really need to push this width out, this simple, this is going to carry that width automatically for me because I'm constrained to the projection. Yeah, it'll be good. You'll get it, I promise. They're the same. Yeah, so I think I extrude this thing, and I think it's 2 and a 16th extruded as well. 2.065 is the extrusion. And I only know that because this is my imagery that I took a screenshot of, and this particular dimension here is how far I've extruded. So I need the same size of circle hole, which is 1.5. That is one of these dimensions in here, right? It's in my list. I know my list kind of looks a little bit different here, but now I can almost start to see here that the hole size is really was a 2-inch hole. And this dimension 6 is my bore size. So I'm probably going to use D6 as the actual dimension for this core. Let me be sure. So what I need is a circle here, right? I do have a constrained rectangle here, but I need a circle for the bore here. And I'm going to dimension that. with the same dimension that the other one is, which from this list is D6. Yours might be not D6, but mine is. You can copy, you can just control C that in there. Then I come over here to my actual dimension and just drop that in, control V. The D6 is actually a driver of the dimensions. You know, it's a that's function. So when I change, if I change this core diameter in some way, this one will automatically change for them. And I want them to be the same, if that makes sense. Yeah, I think I'm showing you just kind of a bunch of different things. And I may even refine these dimensions once I've built it. Once I really know kind of what could really be related to each other, I could sometimes go back through and proofread. I feel like this is more value added than maybe even naming that stuff, is actually just trying to drive like eliminate dimensions that are unnecessary if they're going to be driven by another one. That's I did fix both. So I did go through. Yeah, my first sketch, I did go in and change it as well, and then I changed it in this one as well. So and those could be the same dimensions, honestly, right? Like that is one of my dimensions, and I could use that for my extrusion. So you have to think of the things that are kind of tied together. And this might not be the best way to build this either. It's just that I'm building from something that I already had, which is pretty common in the industry to say, I'm not going to start from scratch. I'm just going to modify something I have. Sometimes it leads to kind of a messy design at the end. Sometimes it is down and dirty and it works great. Sometimes you get to the end, you're like, I wished I would just start this. Maybe it doesn't. Right. And I'm going to proceed with this way anyway, because I feel like this is a messy part. And I don't even like how it really prints, but we'll talk about that. That's a whole other conversation we'll have once we think about the printing aspect of this. I don't think this part is how I would actually really want to do it. I know that now after printing a couple of them. New spec. A hole. This thing here. So you turn this thing. Yeah, it's like skiing. Yeah, it's like skiing down a different lane, but getting to this finish line. Yeah, I'm gonna just do a quick. I'll just do a quick pause and help you out later. Yeah, thanks for reminding me. And yeah, so let's see. Yeah, so I mean, really, it does say that this might not be how I would love to have to modify this, but this is just a down and dirty way to do it. And it may not be the way I would love to do it either. But sometimes just doing it once, learning like what didn't work, I'm kind of better informed to do it again. So I will trudge through something like this and then decide, I probably will rebuild this part at a later date because I don't love it in a lot of ways. But this thing here, I think, should be centered. Maybe not. Let me look at my dimensions that I actually have there. Um, Yeah, okay. So I do have a dimension for you here that is going to be kind of a critical one. I think it's just 1.03125, 1 and a 32nd. Is how far up this needs to be. It's just because they can't be on the same. If I think of the way right now, I just have a connection rod on a crankshaft, and it will be lined up. In our last assembly we had, it was only a single connection rod, and so now I have two connection rods, and they hook up to the same crankshaft, and so they really have to. My piston case has to be slightly offset from the other one, essentially about a the thickness of my connection rod is really a minimum.
that doesn't totally make sense, but so I'm just going to use this dimension and we'll see why when we put an assembly together, why. And if I didn't know this yet and I put it centered, kind of like this other one is, this piston bore is centered kind of in this square shape on this side at least. If I did that here, we'd be in total perfect alignment. And because we have two connection rods on one crankshaft, they can't be in perfect alignment. But we wouldn't know that till if we did put them in perfect alignment, we would see it when we assembled our parts. I'm going to prevent a little bit of that issue and we'll see it. But I have it as 1 and 0.03125. So I'm going to add that dimension here, which is just to the center to here. Is it here or is it? I think it is here. 0.3125 is a 32nd. Yeah. Yes, we did. Correct. It'll still work pretty good. That's perfect then. That's great. Yeah, that's great. Okay, good. 0.3125. I've constrained here. I've constrained center to center here. I think you could do what Ari is saying here and constrain center to you could do center. You could do like a vertical and a horizontal constraint here from kind of the center of the box we just did on both ones. I did a dimension here. Hmm. Now you have to know what dimension you've used for that. So, I mean, like it wouldn't be wrong to say that, oh, this is 1.5 like the other one. Like that's one way that what I'm just showing you is you have like two dimensions now in your list that are kind of doing the same thing. I was able to identify that my D6 is the 2-inch bore in the first sketch. It's really in sketch 2 when I did that, I think. Yes, sketch 2. So this shows me where it lives. It lives in sketch 2. The 2-inch that I times by 7.5. Anyway, this ended up being um this for sure is my piston bore size. So it's really D6. I can just control copy that. And then I came over to my actual dimension. I already slapped a dimension there, but then I just copy pasted that in. And that's how you would make, it's easy when you're in a sketch and the dimension lives in the sketch, just to you're over here, you can select this and that's the f of x. If you'll notice what it's doing is it's calling it D17. That's what it lives at in the list. What I really want is D6 from my list because it really lives in another sketch, which is strange. You can make all this like interconnected relationships that I'm doing here. And there's even more that can be interconnected. I mean, the extrusion length of this part, sorry, yeah, this part here could have been the dimension that was added when the dimension in this sketch here. Then they would have matched, and I wouldn't have had that issue that I did. But then you're building this like what can be hard when you pass this off to someone else that hasn't built this is they don't know where your functions are unless they're labeled and named potentially. That's one of the reasoning for naming dimensions, naming sketches, naming extrusions. It does become more identifiable to someone that doesn't know your modeling techniques, so they can maybe identify it from a name. Um, Otherwise, you have to be the one that's intimately known that, oh, I know that my bores are driving the same dimension. I got to find the one that's driving them. It can be hard. Yeah, it can be like you could create a maze and it's even hard for you to backtrack in. If it's hard for you to remember where it is, somebody else can have a hard time. That's for sure. This one is finished. I'm ready to extrude the length. It's really gonna, I think, be the same length as this from that sketch, which is 2 and a 16. I mean, I could use that dimension. It's this 2 and a 16th. I think it's this one, but it's hard to identify. It really is. So I'm kind of hooking some stuff together, but maybe I'm not hooking everything together. But this length could be connected to this length here, and they would always be the same. So there's some sense there, I guess. Um, More of the story is what I'm extruding is this. I'm extruding it to 065, 260. 60. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 260. 2 Yeah, 2.0625. 2 and a 16. This one measures that when I go from here to here. I think I really show it in the imagery. 2.0625. So this part is kind of done. This is the crankcase part that'll accept two. One is slightly higher up than the other one. And I'm ready to fix my next part. This is the most complicated part to fix, I think. Maybe the piston. I'll go to the next hard one, which is the piston. Well, I'll just hit a quick save on this before I leave it. That one I'm going to save. Even if it's not perfect, just save it with what you've done. And let's see, piston. And I'll take a break here in just a minute. Maybe I'll try to. These ones are really going to be, I think, well, I don't know if they're all that fast. But this one I'm just going to walk through and see what I've got here. I will say one thing. This is a different part, so you really couldn't reference. You really within this part anyway. I wouldn't reference. It has its own f of x spreadsheet here, right? These are dimensions for this part. I really can't say d. I can't really pull from a dimension from another part into here by just naming essentially the parameter name. That wouldn't make sense to it. It's because it's the parameters that are within itself as a part. In an assembly, yeah. There's other ways for sure to do that if you wanted to do that. If you wanted to have more complete dimensions all together in one, yeah, and we will explore how to build assembly that way. Whether the book shows us or not, I don't know. Anyway, so I'm gonna just fix my first sketch and just go down here. So I'll edit this sketch. This is another 2-inch bore, right? So 2. Just gonna say it's 2 times 0.75. I'm going to fix the extrusion length as well. Everything's going to be 3/4 inch down. So this one also could be 0.75 times 0.75. Piston will be shorter. My extrusion 2 is this particular, which was for a 1/2 inch. I'm going to make this edit. F7 to slice graphics for me. Looks like mine was just constrained on the center, like I have constrained center, and I must have it. Yeah, I have this constraint because I projected that geometry. Oh yeah, F7. F7 slices to where you have your sketch. What's that? I mean, my extrusion 2. If you built yours, it's really the F7 to get to that. Yeah, if it lives within the middle of the material, F7. My shell I didn't change. I think even though I didn't change this, I think it's a 0.1 thickness of the shell. I just left that as 0.1 thickness. So that's one thing I did not scale. Is that some thickness, right? That's a good point. The problem with sometimes just straight saying I'm going to scale something down is you end up like having like minimum thicknesses that are not sustainable, right? So thicknesses are definitely affected by scaling, and that's a perfect example of why I didn't scale this. So I think it could be a little thinner, but there's definitely like for a wall thickness. I don't know what our printer likes to do for its minimum wall thickness, but for safety purposes, I didn't switch it from 0.1. And then I just had one more extrusion, which was the cut here. So I do feel like I had to size this down. It's kind of everything is a little too big. But essentially, they're all just the same, right? 0.7, what I was doing. I have these kind of driven together. So one is the driver, one's the driven dimension here on mine. So I only have to change this one. Yeah, you just make an adjustment that you realize that, oh, okay, that's yeah, you don't know what you wished you would have done until you have to go in and change something sometimes. Then you find out, oh, I wish I would have done that. What else was I going to say? And then I don't have to fix my extrusion because my edit feature I said 2 next, and I had already chosen the inside face. of this piston case thing. So that's how far mine was cutting originally in, which just cuts that little cylinder in half like that, or cuts it down the middle. This is all that had to be changed for this one for me. I'm gonna hit save. No, don't always do it the way I do. I am a firm believer that something your own fresh eyes and the way the way you see things can be definitely different. And I think it's worth going, your own struggles will iron themselves out with practice. Mine's a wrist pin is my next one I have, which is a real simple fix here. Yeah, I have one sketch to fix, and it's just the pin diameter here, right? It's going to be 3/4 of that as well. I keep forgetting to put the multiplication. Sorry, 3/8. So this one's that. I think I have to knock down the length of it though. So the extrusion is going to be it's going to be also times by 0.75 is what I'm doing. But you're right. I might use this as my equation right now, and then I might come in and like refine some stuff if I don't like how just a simple multiplication. There might be some things that I might change and actually put in the actual dimension, or make a spreadsheet list of what the dimensions are and how I could tie them together. You could keep your own notes and that'll make you better designers if you're keeping track of what fits with what and what could I drive together and what are my minimum dimensions that I could have. This one's done though. That's just me size and extrusion length. And then this one here, maybe it's just a slightly more complicated for the crankshaft, but I'll just pick it down part by part here. Here's my original sketch. Edit this thing. Ends up being 3/4 inch sizes here. You did a radius. Oh, for sure. Yeah, you could still do it by just you could times your radius by 0.75 or yeah. Hmm. Yeah, this will be it'd be a 3/8 radius, probably a 0.375, right? I'm gonna drop this down to yeah, it's great. Kind of 0.75 by 0.75. Technically, you would think I could drive those together, but maybe there's a good reason for those to be separate. Um, Maybe the distance between the two is not always going to be the same as their billet rate. So those are okay to have two different dimensions. Oh yeah, if it's parentheses, it's a driven dimension, right? I call it a reference dimension, and it's definitely not going to do anything, and you really can't change it. Sometimes, yeah, yeah. I drop reference dimensions in my sketches sometimes just so I can kind of watch that dimension. It might be a dimension that I want to watch how it changes, and I might be want to aware I want to be aware when it changes and I'm not expecting it. So I think adding reference dimensions usually when you add them it'll be like, oh, this is already constrained, you don't need it, but you can say accept and you can plop that dimension in there, and that's just one you can watch. That's a good reason to have one. What is this? I'm going to change this sketch. So if you'll notice, I'm changing my sketch, and then I change my extrusion that's based on the sketch. Pretty much these are going to be even thinner. They're going to be 3/16 is what that ends up becoming, 0.1875 if you're doing the actual, if you're just putting in the number. These are 1/4 inch. And the output is actually 0.1875. It's a 4 decimal place. So. Then I can change this sketch. It's extrusion length. I think I ended up having to change this anyway to put my handle on it. I will go ahead and do its, initially I'll do its 3/4 inch size like that. So times by 0.75. So it's only 3/4. which that one ends up being, I don't know how long that was originally. Two, I think it was two, and it's only three, so it's like one and what, 1.5 now? Yeah. And then my last extrusion and size here. This one I feel like I would like to have, I wish this one would have switched diameter with me when I did the other one because they are the same. So to me, this is a good one for me to say, which is the one controlling D2 from sketch one was not the one I want, I don't think. I think it's in sketch two with that other extrusion. Sketch two, I had a 0.5. So I think it's D5 for me. I wish this dimension, I wish this little pin diameter was just the same as the first time I drew it, which was D5 for me, I think. And that's just because that is the dimension I use to make this diameter. These two I always want to be the same, so that's fine. That'll drive that. I'm gonna say finish that. And then the extrusion length on this is pretty short. It's only a 1/4 inch. I'll go ahead and change it to a 3/4 its length. So I think this one is done as well. I'll save it. And the last one's pretty easy to change. I think it's just one extrusion. I need to change that thickness, but let's do the sketch first. There it is. Sometimes why I might do like I'm kind of thinking in my mind, why did I do a 0.75 times? Sometimes it also helps me maintain the integrity of the original dimension. So, not that I say I'm going to leave them like this, but because to me, I'm kind of doing a test here, right? I'm taking an original part file, changing it to something else. By kind of doing this, dimension times 0.75 is I'm maintaining where I came from and where I went. And then in the event that I didn't like how this turned out, I always have kind of or I have my little roadmap of where I was. Oh, I tried to go 3/4 size. That didn't work. What do I need to change? So, there might be some reasons why you would set up an equation to do some testing first, and then, okay, I'm happy with how that is. Maybe now I'll go in and lock this in, change some dimension to go in. But this is all this needs to change. I need to fix the extrusion thickness, so I don't want to do that. But it's 1/4 inch thick right now. So I'll make it 0.1875 or this time. Gotta be 1.875 to pick it up. This is done, saved. I've got all my parts. Now I need to do assembly, but I'll push pause right here and then we'll assemble it. And then we'll start troubleshooting size. Right now I'm still size on size, so I have that issue. And then we'll jump in. This will be my part one.